Welcome to the next episode of Clean Critically. And today we're tackling dire emergencies such as trichloroethylene. This is excellent ideas for manufacturers brought to you by the Product Quality Cleaning Workshop team of myself and Barbara and Ed Koenigsberg. So Barbara and Ed are the cleaning lady and the rocket scientist. They're with BFK Solutions, who are experts in critical cleaning, and they're there to help you improve your cleaning process.
Darren Williams is the professor. He's a professor of physical chemistry, which a few people understand. And he is also the cleaning research group leader. So he teaches theoretical and practical, and he has industry and academic experience. Oh, isn't this wonderful? We're talking about a proposed rule. In October of 23, the US EPA, this is all the US, proposed to ban the manufacture, including import, processing, and distribution in commerce of trichloroethylene for all uses with longer work compliance timeframes and workplace controls, including an exposure limit for some processing and industrial and commercial uses until the prohibitions come into effect. The rule would protect consumers, workers, occupational non-users, and bystanders from the harmful health effects of TCE. And here's how you find the whole proposed rule. So,
this is all done through the US EPA Amended TSCA process, which has the EPA looking at existing chemicals and assessing what their effect is on workers and the public. And they have determined that there is unacceptable risk to workers for trichloroethylene, which we just were talking about, but also for methylene chloride, perchloroethylene, and an N-propyl bromide, which is sometimes referred to as 1-bromopropane or 1BP.
So where does unacceptable become acceptable?
I'm so glad you asked.
Isn't this fun?
Yeah, so this is again, they're setting these worker exposure numbers even lower, over time. You see here various numbers for these compounds, trichloroethylene and N-propyl bromide, and perc and methylene chloride. The OSHA PEL for quite a while was 100 parts per million for a couple of those, and 25 parts per million for methylene chloride. And then you have the threshold limit values and the Cal OSHA PELs. But this new ECEL, existing chemical exposure limit by the EPA, and this is proposed, are orders of magnitude smaller. So 0.004 parts per million for TCE, 0.05 for MPB, and 0.14 for perchloroethylene. You can see here too, the odor threshold, that's the threshold at which you would begin to smell these compounds, is 100 or 50 parts per million or 250 parts per million for methylene chloride. So if you can smell these compounds, you're way above any of these limits. And like I said, go ahead, Barbara. Yeah.
And you don't want to depend on smelling those compounds because
No, that's never been an acceptable practice.
No. We've had to pick a few people up off the floor because they weren't sensitive to the odor. In any event, that 0.004 proposed is kind of alarming a little bit.
Yeah. But yes, what about the flashpoint inerted trans dichloroethylene?
Yeah, several of these blends have come about, especially for vapor degreasing, where flammability is a risk. They mixed in some non-flammable solvents to inert that flashpoint. Typically, these are perfluorinated alkyl substances, PFAS. They're hydrofluoroethers or some other compound with a lot of fluorinated carbon in it, and that sucks the energy out of that vapor so that it won't sustain a flame. And we wanted those to be azeotrope so they wouldn't separate upon boiling. And so that's where the word azeotrope came from. It's a mixture that the liquid has the same composition as the vapor, and so it doesn't typically separate in a vapor degreaser. And trans dichloroethylene was a great molecule to use in those solvent blends. And it is now been added to the list of risk evaluation chemicals. And so it's on the next group of solvents that's going to be evaluated by the TSCA reform group.
But it's
And there have been a lot of press and news about PFAS in terms of its effect, like largely in water supplies and such, but it is now also under a lot of stress, both from the US EPA, but also a lot of the states are jumping in with regulations.
oh, then what happens? Somebody from high up from EH&S, or maybe the president of the company, comes roaring down the hall saying, change that cleaning process immediately. Stop using trichloroethylene. Stop using all chlorinated and brominated solvents. Help. The sky is falling and all of that. And then EH&S says, well, we have a whole bunch of no-no lists that you can't use and a whole bunch of allowed chemicals and lists of lists. So it gets messy. Then there is the vendor hyperbole. Never happens, does it? They say this cleaning agent works better than TCE and it's perfectly safe. Our process is future-proof. Ain't no such thing, just a hint.
Yes.
And my favorite is everyone is switching to tetramethyl chicken wings, and it works for all soils. Notice I was ladylike and referred to the wings of the chicken as rather opposed to chicken product, but a lot of them suggest other parts of the chicken.
It's important to always ask why. Why do you have to replace the current process? Because a new cleaning process must remove any of the soils or residue of interest. It's got to work at least as well, or preferably even better than the process that you've been using. And very importantly, it should not damage what you're building.
And I think it's important too to understand the regulations. Don't just work in a all solvents are good, all solvents are bad mindset. You need to look into the regulations and how they regulate the use of these solvents. Sometimes there are still opportunities to use solvent cleaning, like in an airless degreasing system or one that's completely enclosed, one where there's never an opportunity for that liquid to be in contact with the room air. Some of those systems will still be allowed to use solvent cleaning.
Let me interrupt. We don't know.
Yeah.
True. True.
Airless systems, there's airless systems and negative pressure rooms, but this is all in the proposed stage. We don't know. So what if you have to jump immediately? What if the boss says you really have to change right away? Figure out where you are. Don't clean as much if you don't have to. Are the as received parts clean enough? Can you get away with something with less cleaning? Can you look at similar halogenated solvents? All of these are being regulated. None of them have as low a level, a proposed level as TCE, but none of them are quite drop-in. We have to look at the regulatory timeline and consider the worker exposure issues.
Let me jump in on the drop-in thing too. Don't take unnecessary risk by just putting a different solvent in a piece of equipment that it wasn't made to use.
Absolutely not. Great point.
Always understand what your system is made for a particular set of chemistries. Talk to your system manufacturer. Don't just go and pick a new solvent and stick it in a system that it wasn't made to work with.
Because they may have different temperature ranges for working. They may react differently on the seals of the device.
They may be flammable.
Some of them are flammable.
You have an open top. It's really not a good idea to either use the hydrocarbon blends or the modified alcohol. There are no drop-in substitutes. We can look at less similar solvents, and you might consider it. Isopropyl alcohol, the modified alcohol, they're different. You can look at water with additives, looking at semi-aqueous, which is basically a solvent blend that is rinsable in water, or a co-solvent blend, which is 2 or more solvent or solvent blends in a row. You can look at non-chemical, non-liquid cleaning, sometimes called no chemical, but we don't mean that. But you just have to evaluate, test, and get your ducks lined up.
Talking about
Earlier about
Flashpoint, yeah. Go ahead, Ed.
Flashpoint inverted trans TCE as a short or medium-term solution. And as we pointed out, it is under TSCA evaluation, so we don't know what's going to happen.
Well, it's
and the
scheduled,
fluorinated
yeah.
inerting agents are also under stress.
3M has actually exited the market, and there are somewhat similar fluorinated inerting agent. How will they be classed as PFAS? I don't know. It's very complicated. You also have to determine the efficacy of cleaning in your application. You have a lower boiling point, which means you decrease the cleaning action. You tend to have a lower solvency. You may have to adjust the process. Don't just drop it in.
And one of the things too, if your cleaning process has really been dependent upon the chemistry, and the chemistry is changing or maybe even decreasing in its potency, you may have to increase the use of forces in the cleaning process. You may have to depend more on impinging and spray, or maybe soaking and stirring, or involve ultrasonics, maybe vacuum cycle nucleation or cavitation. There's lots of different ways to use forces in cleaning, and forces are always important in the cleaning process. So it's one of those areas that, not everything is done by the chemical. That's just one part of the cleaning process.
This is a case where your mummy is right. You want to be the hero, not the victim. Just because the crowd is jumping off a cliff and using tri-iodo chicken wings, that doesn't mean it's right for you. Explore the options, understand the pros and cons. Start to test, start to evaluate, and then you can make rational, informed cleaning choices. Okay, so
yeah, one way of keeping the options on the table is using some of the educational resources, either from BFK Solutions or the team at Sam Houston.
And Ed and I do a monthly newsletter, the official journal of the cleaning lady and the rocket scientist. It's monthly, give or take. It's free. Sometimes Darren writes part of the article. Sometimes one or both of us do.
Sometimes we get somebody else.
But we have fun with it. We give you our best information, and some of the older newsletters, or more recent older newsletters, deal with these topics. So go peruse the website. We also have our handbook for critical cleaning, which after a number of years remains still a decent resource. And we have the webinars and courses from PQCW, some sponsored ones that are free to attendees. This one's free to attendees, and also our on-demand courses, starting with the aqueous cleaning course, brought to you by the PQCW team.
And so we thank you so much for tuning in to this Clean Critically episode on tackling dire emergencies, especially those emergencies that deal with the regulation of trichloroethylene and other chlorinated solvents, and the fluorinated solvents now too. We're trying to give you excellent information to make your products better and to make your cleaning processes better. So we'll see you next time.
Bye-bye.